Four of the world's most powerful telescopes delivered a seismic shock to our understanding of interstellar objects for weeks. Astronomers around the globe have trained their most advanced instruments on 3 Atlas, the third confirmed visitor from beyond our solar system. What they found has shattered expectations and forced a complete rethinking of cometary science. James Webb revealed chemistry that simply shouldn't exist. Hubble captured details that defy explanation. The Very Large Telescope detected elements that rewrite the textbook, and SPHEREx uncovered a size so colossal it's left researchers stunned. After an unprecedented campaign of coordinated investigation, the verdict is in: 3 Atlas is not the comet we thought it was. Here's how 4 telescopes working in concert uncovered a cosmic mystery that's changing everything. On August 6th, the James Webb Space Telescope aimed its near-infrared spectrograph at 3 Atlas, hoping to decode the chemistry of its coma, the hazy envelope surrounding its nucleus. What Webb found sent shock waves through the scientific community. Typical comets, whether from our solar system or previous interstellar visitors like Boris, are dominated by water vapor. But 3A Atlas is radically different. Its coma is saturated with carbon dioxide with a CO2 to water ratio of 8.1. That's higher than any comet ever measured, and it's not even close. Imagine a world where water is a rare trace element, and carbon dioxide reigns supreme. This discovery suggests that 3 Atlas formed in a stellar nursery utterly unlike our own, perhaps near the CO to ice line and its parent protoplanetary disk, or in an environment bathed in intense radiation that vaporized water away. The chemistry is so alien, scientists are now questioning whether our models of comet formation apply at all to objects born in other star systems. The Webb data isn't just a bombshell. It's a direct challenge to everything we thought we knew about how comets form and evolve. Meanwhile, Hubble's Wide Field Camera 3 was capturing the most detailed images ever taken of an interstellar comet. On July 21st, Hubble trained its lens on 3 Atlas, zeroing in on its nucleus and the surrounding coma. What emerged was unlike anything seen before. The nuclear size estimates range wildly from a modest 320 meters up to a staggering 5.6 kilometers in diameter, suggesting a complex, irregular shape. The coma itself, a halo of dust and gas, showed a teardrop-shaped plume and a faint dusty tail. But it wasn't just the shape that confounded scientists. The outgassing behavior of 3 Atlas broke every rule in the book. Instead of the expected jets of water vapor and carbon monoxide, Hubble found almost none. The typical gas signatures were missing, replaced by an unusual asymmetric pattern that hinted at a fundamentally different mechanism of activity. The nucleus was actively shedding material, but not in the way any known comet does. For astronomers studying cometary dynamics, these images forced a reckoning. 3 Atlas was operating on principles we simply hadn't imagined. The Very Large Telescope in Chile took the investigation a step further, using powerful spectroscopic instruments to dissect the comet's chemical fingerprint. On August 21st, the results were extraordinary. VLT confirmed the presence of cyanide, a molecule seen in some comets, but also detected nickel, a metallic element almost never observed in these icy wanderers. Nickel's presence is a clue to the comet's origins. It suggests material forged in the heart of a long-dead star or accumulated in environments rich in heavy elements. The chemical mix found in 3I Atlas is unlike any solar system object. Cyanide and nickel together point to a history stretching back over 7 billion years to a time and place utterly alien to our own. This isn't just a comet, it's a time capsule from a distant ancient stellar system. Its composition speaks of a journey across the galaxy through interstellar space, surviving cosmic radiation and collisions that would have shattered lesser objects. Then NASA's SPHEREx mission added yet another layer to the mystery. Between August 8th and 12th, SPHEREx performed deep observations focusing on 3 Atlas's size and mass. The findings were jaw-dropping. The nucleus could be as large as 46 kilometers in diameter, 10 times bigger than initial estimates, and millions of times more massive than previous interstellar visitors. Like Oumuamua and Boris, such a giant should have been visible long before July 2025, yet it remained hidden, undetected until the Atlas survey in Chile caught it by chance. How can an object of this scale with such a bright and active coma evade detection for so long? The answer may lie in its unique chemistry and physical structure, which could mask its true brightness or scatter light in unexpected ways. This hiding problem is now a major question for astronomers. Are there other massive interstellar objects lurking waiting to be discovered? With 4 independent telescopes, each using different techniques and instruments, the evidence began to converge. The Atlas Discovery Network, spanning observatories in Hawaii, Chile, and South Africa, coordinated a global campaign of observations. Each telescope confirmed the same anomalies: unusual chemistry, unexpected activity, and a massive irregular nucleus. Data from space and ground telescopes align perfectly, ruling out instrumental errors or local effects. When the world's best telescopes agree, scientific certainty follows. The case of 3 Atlas is now one of the most thoroughly vetted in recent history, with each line of evidence reinforcing the conclusion: this is not a normal comet. This is an object forged in the fires of alien star formation, carrying secrets from a time before our solar system was born. But what does all this mean? The evidence is overwhelming. 3 Atlas is not behaving like any comet we know. Its chemical makeup points to a birthplace far from the sun in a region where water is scarce and heavy elements are abundant. Its anti-tail, a backward streak of dust and gas, may be explained by its exotic chemistry and the way it interacts with solar radiation as it hurtles through our solar system. It offers a glimpse into the diversity of planetary systems across the galaxy. This ancient messenger has traveled over 7 billion years, carrying the building blocks of worlds we've never seen. Its rarity is profound. In the vast population of comets and asteroids, nothing compares. And now the clock is ticking. In just 30 days, 3I Atlas will make its closest approach to Mars, passing within 18.6 million miles on October 3rd. Mars Express and Trace Gas Orbiter are primed for a close-up analysis, hoping to capture final clues before the comet swings around the sun on October 29th, entering a period of invisibility as it's lost in solar glare. For a month, we'll lose sight of this cosmic visitor. But in December, as it emerges from the sun's shadow, astronomers will seize their last chance to unlock its secrets before it vanishes forever into the depths of interstellar space. For telescopes, for independent confirmations, one impossible conclusion: 3 Atlas isn't just unusual. It's rewriting our understanding of what's possible in the cosmos. With its backwards tail, impossible chemistry, and billion-year journey from another star system, this ancient visitor is pushing science to its limits as it nears Mars and prepares to depart. The world watches, ready for one last glimpse at the secrets it carries. In these final weeks, we stand on the edge of discovery, confronting the unknown and realizing that the